we will continue working on review problems on vector and forces. Okay, we are in problem 4. Fine, the tension in cable AC is given to be equal to 945 Newton. Find first the angle between cable AC and the boom AB, and the projection of the force in cable AC on AB. So here, as you can see, it's a 3D problem, and they are giving us the tension in AC equal to 945. So let us put it. So TAC is known. It's equal to 945 in magnitude. And since we know that it's passing by points A and C, so using the method of the unit vector, we can find vector TAC. Okay? Now what is the question? First, they want us to calculate the angle between cable AC and the boom AB. Whenever you want to calculate an angle, think about which application. What should we use to find an angle?
The dot product.
Very good, the dot product. So I go back to the definition of the dot product. For the dot product, I can say that cosine of, if this angle I name it theta, so cosine of theta is equal to, I can write it in two ways, okay? I can just say it's unit vector of AC dot product unit vector of AB. Or if you want, I can say it's vector AC, dot product vector AB over the magnitude of AC times the magnitude of AB. So the two are equivalent because you know that here if I divide by magnitude of AC times magnitude of AB, if I take AC vector over AC magnitude, I will get unit vector of AC. And if I take AB vector over AB magnitude, I will get unit vector of AB. Okay? So I can do both. Now, to find the unit vectors, I should find the coordinates of points first. So I look to my figure. I need to find coordinates of A, C, and B. Starting by A, if I look at my figure, it's clear that if I follow the dashed lines, I have A has a component along Y equal to plus 2.7, and it has a component along X equal to 3.6. So from the figure, no component along Z. Because look, for example, if it has a component along Z, they would have done a line like this and gave me the length. Okay? So for A, the coordinates are 3.6, 2.7, and 0. Okay? Now, for point B, it's the simplest point. It's the origin of the frame. So for B, it's simply 0, 0, 0, 0. And for C, if I follow the dashed line also for C, it's in plane Y and Z. So X of C will be 0. And this component represents Z of C, which is 1.8. And this component represents Y of C, which is 3.9. So the coordinates of C are 0, 3.9, and 1.8. Now, once I determined the coordinates of points, it's very simple. I can find the unit vectors. So starting by unit vector of AC, as usual, okay, I take X of C minus X of A, so it's minus 3.6i, minus 3.6i. Y of C minus Y of A, so 3.9 minus 2.7, so plus 1.2j. and 1.8 minus 0, so plus 1.8k. This will give me the vector AC, and I should not forget to divide by the magnitude, so over radical of 3.6 square plus 1.2 square plus 1.8 square. Okay, so this is unit vector of AC. Now, if you want to simplify, I can calculate this number, and just I will call it, for example, x. So I will put that unit vector of AC is equal to this number over x. Okay. Now, for unit vector of AB, I'll do the same. So for unit vector of AB, it's much simpler because B is 0, 0, 0. So vector AB is simply 3.6i plus 2.7j and no component along k. And I divide by a radical of 3.6 square plus 2.7 square. Okay, and now
مش minus 3.6 plus minus 2.7.
yeah, exactly. Sorry, because it's from A to B. Yes. So it's I will put minus outside. Okay. Now the next step to do, okay, is to do the dot product. So if you want, also I will name the radical component. I will name it y to simplify the calculation. And of course, once you write it directly, you calculate it as a number using the calculator. Okay, so it's this over y. And now, when I want to apply the dot product, okay, what do? I multiply the x component together plus the y component together plus k components together. So unit vector of AC dot unit vector of AB. As you can see, at the end for AC, I can take into factor, because it's a common factor for all terms, I can take 1 over x for all factors and 1 over y for the factors of AB. Okay, so because each time, for example, if I multiply x component of AC by x component of AB, what I will obtain? It's minus 3.6 over x, okay, times minus 3.6 over y. So you will see that for all terms, you will have in common 1 over xy. This is why I will do first the expansion, then I will divide at the end by x times y. Okay. So if I do the dot product, it is first for I minus 3.6 times minus 3.6, so 3.6 squared, plus for the y component, it's plus 1.2 and minus 2.7, so it's plus 1.2 times minus 1.7. Okay, and along k, I don't have, it's 1.8 times 0, so it's 0. Okay, so here, what I will obtain now, I should not forget also to divide the result by x times y. And as you can see, it's equivalent to calculate AC dot AB over magnitude of AC times magnitude of AB. Because x is the magnitude of AC, y is the magnitude of AB, and this 3.6 squared plus 1.2 times 1.7 is AC dot AB vector. Okay, so now this is the dot product. I have all numbers. I calculate the dot product, and now I do theta is cosine minus 1 of this result. Okay. Any question on this part? Okay, Bruno, yes. You do the calculation, you find x and y. Yes.
Isn't it negative 2.7? 1.2 times negative 2.7.
It's a typing error. Yes, 2.7.
Okay.
Okay. So here, if you want, let us see the calculation. So you have all calculation down. Okay. So what they did, instead of calculating directly unit vectors, they found first vector AB, then vector AC, and magnitude of each. Okay. And after this, they applied the dot product. So it's XAB times XAC plus YAB times YAC plus ZAB times ZAC, and they obtain our same result. So of course, it's equivalent to do unit vector of AB dot unit vector of AC, or to do AB dot AC over magnitude of AB times magnitude of AC. So this is the result here, as you can see, as we did together. And you can calculate therefore angle theta between the two vectors. Okay? Any question on this part? Okay. Now, the second part, the second question is to find the projection of force in cable AC on AB. So they gave us already what is the tension in AC. The tension in AC is 4945. Okay, so here the tension is equal to 945 Newton. And I want to project this force on AB, on line AB. Okay, if you remember, we have seen before together that for the projection, also we can use the dot product. Okay, but look here, they simplified on us the task. Why? Because already they asked for the angle, and since you have already found the angle theta here, what will be the projection simply? What can you do now? If you want to project a vector on a line, it's a perpendicular projection. Okay, since you know the angle between the two, the projection magnitude is simply 945 cosine theta.
Multiplied by cosine.
Yes. So if I want to write T projection, so TAC projected on AB as a component, okay, is equal to 945 times cosine of the angle theta. Okay. Now, if I ask for, so this is the projection component. If I ask you for the projection vector, what do you do? So what is the projection vector?
The magnitude,
Yes.
multiplied by the angle between these two lines.
Yes, this is projection component is 9 magnitude times cosine theta. But projection vector, it means that I should express. Yeah, this is the vector. Okay. So I multiply the projection component by the unit vector of AB. Okay, because it's like, for example, if you have a projection on x-axis, if you say that the projection on x-axis is 2, the projection vector is 2i, okay, because I is the unit vector of x. Now, if you are projecting on any line, then the projection vector is the projection component times the unit vector of the line. So here, I can say that the projection vector is equal to the projection component times unit vector of AB. Okay, so I already calculated unit vector of AB, and I calculated the projection component. Then I can find the projection vector. Now, in case they
Doctor?
didn't, yes.
What's the difference between projection vector and projection component?
The projection component is just the number. Okay, it's not a vector; it's a scalar. It can be positive or negative. Here you will get a positive result because you have the projection directed from A towards B. Okay. In case the projection was to the other side, then it will be a negative projection, and you will put minus a number. So the projection component is just a number, positive or negative. However, the projection vector, it's a vector, so it has I, j, k components. Okay, so for example, a simple example. If I give you a point on x, okay, on x-axis, the component of this point. So I can tell you if this distance is 2, then you say that the component of c is 2 along x. And if I ask you for the vector, you will tell me the vector is 2i. This is the whole difference. You multiply the number by the unit vector. Then you get the vector. Okay?
Okay, thank you. But the projection here, isn't it the perpendicular of AC on AB?
Yes. Always, always, when you project one vector on one line, and it's not a frame, whenever I tell you project a force on a line, it's the perpendicular. Okay? When you work in frames, it will be different. Yani, if I give you a Cartesian frame, a rectangular frame, and I ask you for the components, you do perpendicular projection also. But if I give you a frame like this with the axis non-perpendicular, then the projection will be different. Okay? But if you have only one line and you are projecting a vector on it, it is the perpendicular. So here, for example,
Okay, thank you.
if you have this vector here, and I tell you project, here it's different, okay? Because you are decomposing in a frame where the angle between the axis is not 90 degrees. So in this case, you don't do the perpendicular. What you do is you take the parallel to the first axis, okay? So like this, for example, if you want to project on this line, you take parallel lines to the other axis, like this, like this. So they will not be perpendicular in this case, okay? But when you project only on one line, yes, you take a perpendicular, okay? So
Okay,
this will
thank
be the
you.
projection here. Now, in case they didn't ask for the first question, if I don't already know the angle, okay? And if they didn't ask A, just they asked me the projection of the force in cable AC on AB, I can find the angle, then do what we did. But the easiest way is that we have learned in the course that to find the projection component of a vector on another line, all I have to do is TAC, okay, dot product of unit vector of AB. So if they ask you, whenever they ask you for the component of a vector on a line, if you don't know already the angle, you will do TAC dot unit vector of the line on which you want to project. And of course, it will give you the same result, because when you do TAC dot UAB, it will be equal to what? It will be equal to magnitude of TAC times 1, which is the magnitude of the unit vector, times cosine theta, okay? But since already theta here is known, I directly used this formula. If I don't know theta, I should find the components of TAC, the components of unit vector of AB, and multiply each term by the other. So it's the usual method, okay? أصلاً نحن تنجيب theta, we found GAC vector and we found AC vector and AB vector to be able to do the dot product. Okay, so here you can see the solution.
Doctor,
Yeah,
sometimes I know the formula, and can we divide the dot product of the two vectors over the magnitude of the other?
can you please repeat the question? I didn't understand what you mean.
Yes. For example, the projection
Yeah,
of a vector on another line,
yeah,
it's the dot product between them over the magnitude of the other.
yes, of the line on which you want to project. So you mean
Yes.
this? It's TAC dot vector AB over magnitude of AB. This is what you mean? Because when you want to project, yes, when you want to project on the line, you should take the unit vector of the line. So the unit vector of the line is AB vector over AB magnitude, okay? But for TAC, you don't divide by magnitude. You take TAC as a vector, okay? And you take AB as a unit vector. Because if you don't divide by AB, you will not have the projection component. This is the idea. Okay.
Yes, here we are getting أنا ضاعت شوي. Here we are getting the projection of who?
Of TAC, of vector TAC. So look here, look, TAC vector you have already calculated. Here, for example, TAC is already calculated, okay? TAC vector is magnitude of TAC times unit vector of AC. So it is, you know the vector already, okay? Now, when you want to project, if you want to project this vector on AB, what you do is you do this vector dot product unit vector of AB, okay? Which is AB vector over AB magnitude. Here in this problem, since already we have calculated the angle theta, no need to use this formula. We can directly say that the projection component is FAC cosine theta. Okay, but what is FAC cosine theta at the end? It's TAC dot AB vector over AB magnitude. Because look, if you don't divide by AB, what do you get? If you don't divide by AB magnitude, you get TAC times AB magnitude times cosine theta. But what is the projection for you? It's only, the projection of TAC is only TAC cosine theta, okay? This is why you should divide, to obtain the component of projection, you should divide by AB, okay? Which is equivalent to multiplying by the unit vector of AB, okay?
Yes.
Okay. Marisa, it's fine. You asked me a question, but I already answered. It's fine for you?
Yes,
Or-
yes, it's fine.
Okay.
Thank you, doctor.
Well, okay. So let us continue now. Okay, another problem. Determine the magnitude of the projected component of force F acting along BC. Okay, so here it's the same. If you want, it's the same idea. We want to project a force on an axis. Okay, so first let us look at the given. What do we know in the figure? We know the magnitude of F, okay, and we know all coordinates. So we need to project F on BC. This is the question, okay? So the idea is what we should do here. What is the definition of projection? So if I want to project a force on a line, I should do, so the projection component is simply F vector dot product unit vector of BC. Okay, so this is what I should do. I should find the force F, and here I can find it because I know the magnitude of it. It's given. Okay, the magnitude is given, and I have the 2 points. The force F is passing by 2 points C and D. So all I have to do is to find coordinates of C, coordinates of D, and find the unit vector. And for BC also, for BC, I determine coordinates of point C. I get vector BC, and I divide by magnitude of BC to get the unit vector of BC. Okay. So this is the same idea. So can you please try to practice with this problem? And if you have any problem, you just text me. Okay. So it's the same method. So nothing is new here, but it's for you to practice more. So as you can see here, we should find the unit vector of CD, the unit vector of CB, and then to find the projection, we do FCD dot vector unit vector of CB. Okay. So since it's the same idea, I will go to another problem, but please try to practice with it.
Best doctor, I have a small question. فينا نطلع شوي?
Yes, sure.
In the solution that they wrote تحت.
Yeah.
They wrote F of UCD dot UCB. شو الفرق إذا كنا كتبنا UCD مش F of UCD؟
ما هي ذاتها هي ال f هي ال vector f. How you will find it? You know that f is passing by points c and d. So f vector, to calculate f vector, you should find the unit vector of cd. So it's the magnitude of f times unit vector of cd. Okay? Because look, to find f, you should pass by the unit vector cd, since you know that f is passing by points c and d. Okay? So you don't know directly the components of f. You know that it's passing by these 2 points. So how you calculate vector f? So to calculate vector f, it's the magnitude, which is given 100, times unit vector of cd. Okay?
Okay,
This
so
is-
when we write of
Yeah.
UCD 100 times CD,
Yes, yes.
okay,
Because if you
thank
have
you.
a factor, if you have a vector, you know its magnitude, and you know that it's passing by 2 points, then you define the vector as the magnitude times unit vector of the line of action of the force, which is here line CD, okay? And you are able to find unit vector of CD by calculating the coordinates of C and D, okay?
Okay, thank
For example, here D is on y-axis, so it only has y component. The y component of it is the total length here, which is D plus B, okay? While for point C, if you want to find coordinates of point C, you follow, look, you follow the dash, the lines here. So you have that C has 3 components. It's along X, it has component C plus C, okay? Along Y, it's plus D. And since it's below Z axis, it's a negative Z component, it's minus E, okay? And once you have all coordinates, you find unit vector CD. Okay. Here, since they, if they, in general, they should, here they said project along axis BC. They didn't give a certain preferred direction. And they didn't say on vector BC or on CB. So this is why you are free to take a BC or CB. Okay. This is why here they considered UCB, because maybe in the figure it seems that it is positive along UCB. But you can take what you want. And in general, when they tell me project on BC, I take unit vector of BC, just unit vector of BC. Okay? So it's up to you. It's not wrong. Both are right. It's fine. Okay. So let us continue with problem 6. Determine the angle theta between the 2 cables attached to the pole. So here also, since we want to find an angle, so we will do the dot product application. But what is little bit tricky and difficult here is to find the unit vectors, because we have a new way of definition of forces. We have already practiced together how to define a force if we know 2 points. So if we know 2 points, it's passing by points A and B, for example, all I have to do is to find unit vector of AB, okay? Here, we are presenting other methods that are used to define a force, okay? So first, for F1, what did they give us for F1? Look at the figure. They gave us 2 angles, and these 2 angles will define the direction of F1. Okay, how? If I look at my figure, okay, this is vector F1. It's doing, if I project it on XY plane, okay, I have, this is alpha here. This angle here is alpha, okay? And then this will help me in finding what? If I know alpha, I can calculate this part, the length here of this part, okay? Because look, this is a perpendicular projection. So here I have a right triangle. Since I have a right triangle, what will be the length here? I will call it L. What will be L?
F1 multiplied by cosine alpha.
Very good. So L is equal to F1 times cosine alpha. Okay? So now, if I want to project, then this line is not along X, is not along Y. I want to project it along x and y. This is why I need a second angle. So they gave me angle beta here. Okay. Since they gave me beta, so now we can write together. So what is the projection of F1 on y? It is equal to L times what?
L cosine beta.
Very good. L cosine beta. Okay. And now if I replace L by its value, then the projection on y is F1 times cosine alpha times cosine beta. So this is for the projection on y. Now give me what is the projection on x?
L
How to find
sine
it?
beta.
Very good. F1x is L sine beta, and it's equal to F1 cosine alpha, but instead of cosine beta now, it's sine beta. Okay, so here sine beta. And what about F1z? What is F1z?
Sine, okay, F1 sine alpha.
Yes, but it's minus. Why? Because look, it's in the negative z direction. Okay, so F1z is minus
Yes.
F1 sine alpha. Why? Because look at the figure. This is F1z, this length. Okay, this length here you can find it in this triangle because this is alpha. Okay, so this edge is opposing the angle. So to find this projection in magnitude, it's F1 sine alpha. And why it's negative? Because it's pointing down. Okay, so this is how here I can find the components of F1 along X, Y, and Z. Okay, so from here, who will tell me what will be the unit vector of F1? If I want to find the unit vector of F1, what should I do? Unit vector of F1 is F1 vector over F1 magnitude. And as you can see, it will be simplified F1y because F1x is F1 times cosine alpha sine beta. So if I divide by F1, what do I get for the unit vector? My unit vector will be cosine alpha times sine beta along I. What will be the component along J for the unit vector? Plus
Cosine alpha cosine
alpha,
beta.
cosine alpha cosine beta, okay, along J. And along K, it's minus sine alpha. Okay, so this method will tell you that if I know two angles, one of projection on one plane and another angle with one of the two axes, I can find the unit vector. Okay, so please understand well this method because sometimes, and always you have to derive these because sometimes instead of projecting on XY plane, they project on YZ, for example. Okay, but it's the same procedure. And sometimes instead of giving you beta with Y, they can give you beta with X. So it's the same method, but instead of having here, if beta was angle with X, so then with I, the component will be cosine alpha cosine beta. And with Y, it will be cosine alpha sine beta. So it just depends on what are the two angles I give you. But the method is the same. I project first, I find L, then I divide L into two components. Okay? If this is not clear, I can repeat. Any question on this method? Okay. So now,
Doctor, I have a question.
yes.
How did we know that it was a right angle? Because I couldn't figure it out clearly from the beginning.
Okay. Because look, yes, it's true that in 3D it might not be clear, but whenever they give you an angle with a line, this means that it's a perpendicular projection on the line. Okay, so here, as you can see, they told you that alpha is the angle between this line and this one, and this represents the projection of the vector on xy, okay? Because this is a way to divide a vector into components. Whenever you have a rectangular, here you have a rectangular frame, okay? So if you have a vector in a rectangular frame and you want to decompose it into components, what do? You take the perpendicular projection first, okay, like this. Then this line, you divide it into two components by doing also perpendicular projections, okay? So here, instead of giving you fz, fx, fy, what they did, they gave you fz and the projection of the force on plane xy, okay? And since you are working here in rectangular component, so if you want to project on xy plane, you should take the perpendicular to the plane, okay?
Oh, okay, thank you.
Well, okay. Now for F2, how they defined vector F2? They gave us three angles. They gave us the angle of F2. Just 1 second, please. Okay, so for F2, they gave us first the angle of F2 with Z, it's gamma. The angle of F2 with epsilon. The angle of F2 with Y, it's epsilon. And the angle of F2 with, so they didn't give us the angle with X, just they gave us the angle with Z and the angle with Y, okay? But what is clear here, that the projection along X, because if you follow this line, the projection along X is in the negative direction. Why they didn't give us the third angle? Because as I told you, we can calculate it. If you remember in the course material, we said that if they gave us a vector force, they can define it as its magnitude and the angles it's doing with the three axes. But if they gave us just two of the angles, we can find the third because they are related by which relation?
Cosine square.
Yes, very good. So here we
Yes.
have angles epsilon, gamma, and the third one, let's say it's here already we have beta and theta. So let's say I will call it X, okay, angle X, okay? So I have angle big X represents the angle of F2, so it's the angle of F2 with a small x, okay? And I already have the angle, so this is unknown, I don't know it. I have epsilon is given, okay? It's the angle of F2 with y, and it's equal to 60 degrees, okay? And gamma is the angle with z, okay? And it's equal to also 60, okay? So now what I will do, to find the x, I will say since x, epsilon, and gamma are the direction angles, okay, are the direction angles of F2, okay, then what can